Hello everyone. Today we'll be talking about storms, so please brace yourselves. My name is Łukasz Gebel. That's my friend Michał Koziorowski. We're working in TomTom as software engineers. We're working in Łódź, but we also have a new office in Poznań. That's our fabulous team. So as you can see, every day we're fighting for better code and better systems. We're also representing Java user group Łódź and taking part in Jackmeister contest. So let's move to the agenda. So first of all, I will tell you what is Apache Storm. Then I will move to key concepts, tell you a little bit more about infrastructure as it's related to distributed systems. Then Michał will run some code and analyze it to give you some big pictures of the concepts that I was talking about. And in the end of time, as usual, we run out of time, but we will leave you with some further reading topics, interesting topics for further reading. So what is Apache Storm? So Apache Storm is a framework for distributed processing of data streams in real time. So these three phrases, distributed processing, data streams, and real time are phrases that depicts the best features of Apache Storm. So it was created by this smiling young guy, Nathan Martz, and his team for Twitter. Twitter used it for analyzing tweets because probably they did want to know what are you tweeting about. Then they realized it's quite good, quite fast, so they came with the idea to open source it. They put this project into Apache Storm incubator, and now it's free and open source, and everyone can use it. The main feature, one of the main features of Apache Storm framework is that it provides relatively easy way for performing distributed computations. So, briefly speaking, it helps you to avoid JDD. Do you know what JDD is? Yeah, probably you didn't hear about it. So it's gut-driven development. And you do gut-driven development when you're writing your code, it doesn't work, and you're like, oh my God, please make it work, please. I will be a good man, no more swearing, no more alcohol, yeah? So Apache Storm will probably help you to avoid this JDD idea. Who uses Storm? So to put you into context of applications of Apache Storm, we have chosen three big players. So Yahoo, Spotify, and InfoChimps. Yahoo, according to the engineers, they're using Apache Storm for everything that you can see on Yahoo portal. So every dynamic content is processed by Apache Storm applications. Spotify uses Apache Storm for running their music recommendation algorithm. So if you hate their music recommendations, you can blame Apache Storm. And InfoChimps, the company with really nice logo of wandering chimpanzee, they've got a big data enterprise cloud. They provide Apache Storm as a service of this big data cloud. But one of its use cases is processing clickstream web data flow. So summing this up, if you've got big volumes of data and you want to process them quite quickly, Apache Storm is a good choice. So now let's move for key concepts, as our brains like key concepts, and Kanye likes keys. So the first key concept is tuple. Tuple is simply the main data structure in Apache Storm. Is a named list of values of any serializable types. So why it needs to be serializable? Apache Storm applications lives in distributed environment. So your data, your tuples, are going through different nodes, so they have to be firstly converted to byte streams and then recreated on another nodes and used, processed by other components. So here you can see the example tuple with ID, message, and a nickname. So it can be, for example, a tweet. Do you know what's the name of this item? Any ideas? No. Yeah, that's quite hard question. That's spout. So in Apache Storm, spout is the source of the stream. So you can imagine this quite easily, that tuples are pouring down the spout. So it gets data, usually from some external data sources, like external queues, like Kafka, Amazon SQS, like Kestrel, or external APIs, like Twitter. You can download tweets and process them. You can also integrate it with your database, with any data source that you want to. So it produces tuples for further processing. So in real life, there are different kinds of spouts. One of them are quite majestic. Let's say they have big, powerful capacity. On the other hand, there are these kinds of spouts. So let's say they are less spectacular. Sorry, less spectacular. But please don't make laugh of this little guy. Oops, something. Sorry for that. Yeah, don't make laugh of this little guy, as he's constantly pissing since 1619, and he's got really good SLA, really good SLA. So I think that you don't need really good, powerful spouts. Sometimes small but reliable spouts are quite sufficient. In Apache Storm context, you've got two main types of spouts: reliable spouts and unreliable spouts. So reliable spout is a spout that can retry failed tuples. So when it sees that tuple was processed unsuccessfully, it just gets it and sends it for process again. On contrary, there is unreliable spout, which doesn't really care about tuples it produces. In many real-time applications, you can imagine that when the spout realizes that the tuple, a piece of data, was processed unsuccessfully, it may be too late to retry it. So there is no need for retries. Your spout doesn't care about it. So spout is usually a class that implements iReach spout interface. So the next component, who's this guy on the left? Usain Bolt, yeah? So he's quite fast, and in Apache Storm we also get fast bolts. That's the processor, I would say. So that's the component that takes tuples from spout or another bolt, process tuples. It can filter, aggregate, do any kind of processing that you need. It's quite atomic. And produce next tuples or ends the processing. So Bolt usually implements iReach Bolt interface or our basic Bolt interface. And the idea is that in iBasic bolts, you've got the method that is processing your single tuple, and after calling it and returning from this method, the tuple is acknowledged to be successfully processed automatically. On the other hand, in iReach bolts, you control when you find that tuple was processed successfully. So you can do it at the beginning of the processing method, in the middle. You can fail the tuple when you think that tuple was processed unsuccessfully. So you've got the full control over tuple processing and hacking and failing them. So the next thing, that's something for network geeks. So it's a topology. Topology is, formally speaking, directed acyclic graph. So it's a set of spouts and bolts that is responsible for processing your data. So simply, you just set some spouts at the beginning, bolts that are doing some processing things with your data. You build the flow, and that's how your Apache Storm application looks like. Sorry. So you simply use the topology builder when you put your component spouts and bolts in proper order. Then you can run, for example, local mode to test your application, to test your inputs and outputs. And when you deploy it to the cluster, the topology starts working, and the tuples are distributed through your machine nodes. Yeah, so how Storm handles guaranteeing message processing, how it knows that the tuple that was processed by some distributed nodes were processed successfully or unsuccessfully. So there are different levels of guaranteeing message processing. The basic level is best effort. At this level, Apache Storm just sends a tuple and it hopes that the tuple will be processed, but there is no guarantee. It just do its best, but there is no guarantee. So in this case, you're using unreliable spouts that emits tuple and forgets about it. In at least one model, you've got guarantee that every tuple will be successfully processed at least once. So you have to use unreliable bolt that will retry failed tuples. And exactly once model, it is called Trident. It's fully stateful model, and in this model, every tuple, you've got guarantee that every tuple will be processed exactly once. But that's the topic for another presentation. So when tuples are act, the signal ACK is sent. When the tuple is processed successfully or fail, when the tuple is failed. But how Storm builds this knowledge of the whole tuple is processed successfully or failed. So there are two ideas. It's called anchoring mechanism, and there are eking and failing tuples and messages timeout. So every tuple which goes from spout has set message timeout. For example, if you set it to 30 seconds, if spout don't get the ACK signal for this tuple that it was processed successfully, the tuple will be failed. And what about successfully processed tuples? The Storm builds a tree. So now please imagine that the cow jumped over the moon. So the cow is quite confused, so make her just jump. Imagine that you've got the spout that emitted the sentence "the cow jumped." Apache Storm builds a global, in your distributed environment, builds a global tree of such tuple. Then imagine that we've got the splitter bolt that simply splits this sentence to separate tuples. So you've got the main tuple, then you split it to 3 tuples. The cow jumped, and then you consider the cow jump tuple as processed successfully, so you send ACK signal. At this moment, Apache Storm removes it from the tuples tree, so it is removed. Then the tuple, cow tuple, and jump tuple are ACK'd, so they are processed successfully, and Storm removes them one by one, and after removing all of them, the tuple tree for the cow jumped is empty, and that are identically looking twins that are standing in front of each other, and one of them say, "You're ugly." And after such situation, they don't want to talk to each other anymore. So please make sure that zookeepers sees each other in your network, because in other case you will have some problems. So after zookeepers, we've got the last node, the supervisor, and the supervisor is the guy who is doing all the job. So that's the nodes where your topologies are running. It runs 3 kinds of abstractions: workers, executors, and tasks. So worker is a simply single JVM. Executor is a thread, and a task can be, for example, a spout, a single instance of spout, or a single instance of bolt. But by default, one executor have one task. If you will configure it other way, as in this example, then the one executor will be switched to 2 different tasks. But by default, and in my opinion, that's a good idea, is to use 1 task per 1 executor and 1 worker per 1 node. But, yep.
What happens if the spout
if the spout dies, it will be recreated. Yeah. In general, yes, and it's your job to write it to be fail fast. Yeah. Okay, so to run and set up a cluster, you need to deploy three types of machines: Zookeeper's Nimbus as supervisors, and Storm UI, which is optional tool for monitoring, but it's very useful. You should run these processes under supervision, so when one dies, it will be quickly restarted again. So you can use, for example, a supervisor tool. Then you build your topology jar, you deploy it to the Nimbus leader, and your topology starts working. And that's all. So now may demo gods shine upon our keyboards. Michał, release the code.
Hi, I will just show you the, I think, simplest example of the Storm topology, and it will be the word count example, the same one Łukasz shown previously. So there were three parts of the topology. It was a spout producing sentences. Next there was a splitter that splits the sentences into the words, and the last part is the counter that just counts how many times the word happened in all the sentences. So here's the example of the spout. It implements the iReach spout interface. Here I have a couple of sentences from popular English nursery rhyme, and the things you always need to implement is the method declare output fields. Here you declare what will be the output of the storm. So I created a class topofields with all the fields that can exist in my topology. It will be sentence, word, and count. And here I declare that the output will be just the sentence. Here's the way to configure additional options of the spout. In the default example, I'm returning null, which means no additional configuration. But for example, I can configure option like topology max spout pending, and that will mean that the spout will produce 1,000 tuples, and then it will wait before producing next ones until the previous one, at least one previous one is acknowledged. This is the open method which prepares spout for functioning. So basically, you don't declare all the needed components in the constructor of the class. You usually do it in open method. The collector, here's the collector field. This is the thing we use to output tuples or to acknowledge tuples. Here I create also some random number generator, and here I'm getting some from the context some spout ID. In the close method, you basically should close all the resources you use to clear when you are shutting down your topology. But there is no guarantee that that method will be called, because often or always the supervisor machines are killed with kill-9 command in Unix, so there is no much time for closing. Here is a method activate that is run after the spout is prepared, and method to deactivate spout, to just shut it down stop it for a moment. And the next tuple method is the main method of the spout, and it is used to produce tuples for the processing. So here we have a very easy spout that is just getting a sentence from the sentences collection and gets random one. Our spout is, I wanted it to be reliable, and reliability in Storm looks like each tuple from a spout contains a message ID, and when the whole tree from the whole Storm tree, so whole sentence is processed in all the next components, the spout tuple is acknowledged or is assumed failed. So that sentence ID here comes into that method, ACK or fail, as a message ID. You can do with it whatever you want. You can implement some retrying here, or for example, put it, change the visibility timeout in some queue, or anything else. The same happens on fail. So this is some sentence ID I created. So very simple one with some ID, the sentence we are going to process, yeah, and there is a simple toString method. So the next one will be the first bolt. So the first bolt is the split sentence bolt, and it has it implements Irish bolt interface. So it's also very simple. It has a prepare method, which is equivalent to open method from the spout. So it prepares the bolt to working state, and it has an execute method, which is the main method. So here I'm just getting the sentence from the spout. So input gets string by field. I'm getting the sentence. I'm just splitting it to the collection of words, iterable of words, and then for a single word, I'm emitting a new tuple with just that word. And I'm acknowledging the input tuple, so from the tuple, so the tuple from the spout. I have also the cleanup method and declare output fields method, which is equivalent to the one from the spout, and also some get component configuration, which I also leave default. And the last component of our topology is the word count bolt. So basically, in the execute method, I'm getting the word from the previous step. I have a map of the counts, and I'm here increasing that count, and basically that's all. But I've implemented here also some special feature from Spout. So in the get component configuration, I added an option to get also a tick tuple. So this is the special type of spout that is created automatically by the Storm. If you use that option, and when you use it, it will each 5 seconds it will push a tuple called tick tuple to your execute method. So in this case, if the tuple is the tick tuple, I will just log count of each word that came into that bolt and emit it for the future use, but there will be no future use. So it can be used later if someone will implement that. And I declare that, the output of this bolt will be two fields, the word from here and the count. The last thing required is something that will glue it all together. So there is a very simple main class with main method. So here I have topology builder, in which I create the spout. I name it spout, and I create the spout. I also say that there will be only one spout in our topology. I'm adding also the second component, which is the splitter. I initialize it here, and here I define that I want to have two splitter boards. Let's say for performance, to increase performance. And here I'm setting that it will get shuffled data from the spout. So the sentences from the spout will get random split sentence bolt. And the last one is the counting bolt, which I call count. And I said that I want, let's say, 3 of them. Why not? But here I want to get into that bolt. I want to get data from previous bolt grouped by the word field. It means that the same word count bolt will get always the same words from the previous bolt. So here I have a very simple configuration. So I am just disabling debugging and create topology, and I have two ways. I can run the topology locally, so for the debug mode, or I have part that deploys on the cluster. So I can just run it from the IntelliJ. It will be run in the local mode. It runs it started to produce data. So here the spout emitted some sentences, and almost immediately it gets acknowledged because it's very simple code. But after each 5 seconds, the tick word bolt is producing, let's say, statistics from the tick tuple. So here we can see that the word away happened only once, and that statistic was produced from the tick word bolt, which ID was 22, and after next 5 seconds, I can see that the counter increased, and the statistic for that word was produced by the same bolt. So the hashing works. Then I can show you how to deploy it to the simplest cluster. So for the cluster, to have a cluster, I need 2 components. I need Zookeeper and Apache Storm. The simplest working Zookeeper is I just unpacked it and created a simplest configuration, in which just the only changed thing is the data directory, so the place where Zookeeper stores its states and database. And I also unpacked the Apache Storm and created a simplest configuration. This is the simplest one. So I need to point to the place where Zookeeper exists. I have only one on localhost. I have a local directory where Storm stores its temporary data and unpacks the topology. I need to point to the Nimbus machine. Everything will be stored on only one machine. And I need to create a couple of slots for the topologies. Here I create 4 ones, which will mean that there will be 4 workers, so 4 JVMs running on that single machine. And that's all. So I can just start all the components. I start Zookeeper. And Nimbus. Storm Nimbus. Supervisor. Oops, sorry. UI, which is an optional component, but very nice. Storm Supervisor, on which the topology is really run. Log Viewer, which is also optional component, but also nice. And after everything is run, normally you run that component on each of that component on different machines. You can just copy the whole Apache Storm directory to many servers and just run the different components of it. And the last thing I need to do is deploy topology on my Storm. So here I run just Storm jar, sorry. I need to point to the jar containing topology. I need to set the main class, and I name the topology awesome topology. Why not? Yeah. So it's deployed on the cluster, very small cluster, but still. And because I created Storm UI, I have a server that can give me some statistic. So we see here that we have only one supervisor, so the machine on which the topology is run. We have only one Nimbus. Here I see 2, but it's the same one. One is just localhost and Gebel. It's let's say bug. And I have one topology running on the cluster. Here I can see the statistics from for the topology. I see that the spout emitted 200 sentences, and the counterbolt emitted 320 counts, and the splitter emitted more than 1,000 sentences. I see how many were act, how many were failed, and capacity when it goes close to the number 1, close to the value of 1. That means that component of your topology is process data too slow. For example, you see that execute latency, so how long the average execution takes of the code. You can also visualize our topology, which is a nice feature. You are getting the graph, so you see the spout is producing not really many sentences. The splitter is producing a lot of words, and you see the average how long it takes to average produce or process the tuple. And I also started a log viewer, which allows you to to check logs of your component. So imagine that you have a lot of servers, like 600, and you want to check what was wrong somewhere. So we go, for example, to the splitter component. You see the multiple executors, and you can click here and read the logs from the machine. So, yeah, basically that was all I wanted to show. There is one more thing with the spout here, because you can think that of each Storm component that is run in one thread. So it means that the next tuple method, ack and fail, is run in one thread. So the first is run, for example, next tuple, then ack fail, and then next tuple ack fail. So if you will put here something that takes a long time and blocks, you will get acknowledge or fail signals slower. So don't put here anything that it takes a lot to get data for the spout to emit. Yeah.
Okay, Michał, thanks. Good job. So, as I predicted, we're running out of time, but few more remarks. Yeah. So, if you're interested in Apache Storm, you would like to know more of its features. So, there is this Trident model, which I talked a little on the slide with levels of guaranteeing message processing. So the Trident is itself a wrapper on Storm, which have functions, filters, joins, and all of this functional stuff. You implement them, then you build one chain of this kind of let's say functions, and this chain is then converted by Trident to Apache Storm topology for you under the hood. And this model is, as I said, fully stateful, so you probably have some database in which the state will be kept, or you can use in-memory state, some caching, all of this stuff. The next interesting thing is resource-aware topology. So you can imagine situations in which some of your components, like spouts or bolts, have special needs for memory or CPU. And in resource-aware topology, you can set such components to different types of machines. For example, in your cloud environment, you've got different machines, memory optimized, CPU optimized machines. So you can set that this particular type of boards will always land on CPU optimized machine. There is also a feature on Azure Cloud called HD Insight, which sets a full cluster of Apache Storm for you. So it sets nimbuses, zookeepers, and supervisors. You have to just deploy your topology. So I think the final words are, if you're a new player in distributed processing, I encourage you to play with Apache Storms. It's really quick to set up. The idea, the methodology is quite simple to understand and use. And if you're an experienced developer, I think it can solve a lot of your problems when you're dealing with processing big data or large volumes of data in real time. So that's all. Please rate our presentation, and if you have any questions, you can just come to us and we can talk. Will be today and tomorrow available in the conference space. So thank you very much.